Have you ever wondered how our home, Earth, came to be? Billions of years ago, before life, before oceans, before even the atmosphere, Earth was nothing but a fiery, chaotic mass. But how did it transform into the beautiful blue planet we know today? Let's explore the incredible journey of Earth's formation in great detail. The formation of the solar system. It all started about 4.6 billion years ago. Our solar system was nothing more than a giant cloud of gas and dust floating in the vast emptiness of space. Then something extraordinary happened. Gravity pulled this cloud together, and at the center a star was born, our sun. But the story doesn't end there. Around the newborn sun, leftover dust and rocks began to collide and merge, forming the building blocks of planets. One of these was Earth. Over millions of years, these space rocks clumped together due to gravitational attraction, forming a larger and larger mass that would eventually become our planet. A molten, violent world. As Earth took shape, it was an unrecognizable world. The young planet was a molten sphere, covered in lava and constantly under attack by asteroids and comets. These space rocks rained down upon Earth, bringing not only destruction but also essential minerals and elements. The immense heat generated by these impacts kept Earth in a semi-liquid state, with heavy metals sinking to the core and lighter materials forming the outer crust. This process, known as planetary differentiation, created the layers of Earth as we know them today: the core, mantle, and crust. The early Earth was nothing like what we see today. It was a hellish world, covered in molten lava, constantly bombarded by asteroids and comets. There was no land, no water, and certainly no life. Temperatures were scorching, and the surface was unstable. But these violent beginnings were crucial for shaping the planet. As time passed, the intense volcanic activity played a crucial role in reshaping the planet's surface. Volcanoes spewed out gases which started forming a primitive atmosphere composed of water vapor, carbon dioxide, sulfur dioxide, and nitrogen. The giant impact and the birth of the Moon. Then came one of the most defining moments in Earth's history. A massive object, roughly the size of Mars, collided with Earth. This catastrophic impact sent debris flying into space. Over time, this debris came together to form our Moon. This event not only gave Earth a natural satellite, but also helped stabilize its rotation. The newly formed Moon affected Earth in several ways. It slowed down Earth's rotation, preventing extreme fluctuations in climate. It also created tides, which later played a crucial role in the emergence of life in the oceans. The arrival of water. Despite its violent past, Earth began to cool down. Comets and asteroids filled with ice crashed into the planet, delivering vast amounts of water. Over millions of years, rain poured down, filling the deep craters and creating the first oceans. Water became the foundation of everything that followed. As the surface cooled, solid landmasses began to form. The interaction of volcanic gases and water led to the development of Earth's first weather system, with clouds forming and precipitation cycling water between the land and oceans. The chemical reactions between minerals and water started to create the building blocks of life, the origins of life. With oceans in place, Earth had the perfect conditions for something truly miraculous: the birth of life. Tiny, single-celled organisms appeared in the oceans, harnessing energy from the sun. These were the first steps toward the rich and diverse life that would eventually cover the planet. The first known life forms were simple, microscopic organisms that thrived in the nutrient-rich waters. These early life forms evolved over millions of years, developing the ability to use sunlight for energy through photosynthesis. This process released oxygen into the atmosphere, gradually changing Earth's environment. The Great Oxygenation Event. The presence of oxygen led to one of the most significant events in Earth's history, the Great Oxygenation Event. As photosynthetic organisms continued to produce oxygen, it accumulated in the atmosphere, leading to the development of the ozone layer. This shielded Earth from harmful solar radiation, allowing more complex life forms to evolve. The changes in atmospheric composition also led to dramatic shifts in climate, setting the stage for the emergence of multicellular organisms. The formation of continents and changing landscapes. Over hundreds of millions of years, Earth's landscape changed drastically. Continents formed and drifted due to plate tectonics. Mountain ranges rose and eroded, shaping the planet's surface. Life evolved from simple bacteria to complex marine creatures. Eventually, the first land plants appeared, followed by insects, amphibians, and reptiles. Each stage of evolution brought new challenges and opportunities, leading to the incredible biodiversity we see today. As time went on, Earth went through extreme climatic changes. Ice ages came and went, covering large parts of the planet in thick ice sheets. These freezing periods were followed by warmer interglacial periods, where ice receded and new ecosystems flourished. These cycles played a significant role in shaping landscapes and the migration of species. Mass extinctions and evolutionary surges, volcanic eruptions, asteroid impacts, and shifting tectonic plates caused mass extinctions, wiping out many species but paving the way for new life forms. The most famous of these extinctions was the event that led to the demise of the dinosaurs about 66 million years ago. This allowed mammals to thrive and eventually led to the emergence of early humans. The rise of mammals and humans. The evolution of life continued with the rise of mammals, birds, and eventually early human ancestors. Earth's changing environment led to adaptations and new survival strategies. The continents continued to drift, affecting ocean currents, weather patterns, and global biodiversity. The formation of mountain ranges, deep ocean trenches, and vast deserts all contributed to the dynamic evolution of ecosystems. Human civilization marks the most recent and dramatic transformation of Earth. Early humans adapted to their environment, developing agriculture, building cities, and altering landscapes. Industrialization and technological advancements have significantly impacted Earth's atmosphere and ecosystems. While human activity has accelerated climate change, our species has also developed ways to understand and mitigate environmental challenges. The future of Earth. From a swirling cloud of dust to a molten world, from endless oceans to a planet teeming with life, Earth's journey has been nothing short of incredible. And even today, our planet continues to evolve. Climate change, natural disasters, and geological processes continue to shape the planet, reminding us that Earth is still an ever-changing world. Scientists predict that in the distant future, Earth's continents will continue to drift, potentially forming another supercontinent. However, billions of years from now, the Sun will eventually expand, consuming the inner planets, including Earth. While this future is far beyond our lifetimes, it serves as a reminder of the ever-changing nature of the universe.